Okay, Assalamu alaikum wa rahmatullah. For today, inshallah, we are going to continue our class of yesterday. So we are still in the database design stage. So yesterday we learned some things. Yesterday and a day before, we learned how to describe the database design phases, and we started to learn how to create the entity relationship diagram, and we learned many things about the constructs of the entity relationship diagram. For today, inshallah, we are going to complete this part, and inshallah, we will start with the next step of the transform from entity relationship diagram into relations, inshallah, next week. Yesterday, we stopped somewhere here. We stopped here in this slide. Okay. Okay, if you remember yesterday, we already took the examples of multiple relationships and also the cardinality. We learned about the what they call it, the degree of the relationship, which is called cardinality. So we learned about the unary relationship and binary, ternary relationship also. After that, we learned about the one-to-one relation, one-to-many, many-to-many, and we took some examples for the unary relation, which is a relation that's conducted between the table and itself, and the binary relation, which is conducted between two tables, and the ternary relation, which is conducted between more than two tables. After that, we learned about the cardinality constraints. So we learned about these shapes, how we are going to use the shapes, what's the meaning of the dash, what is the meaning of the O, and so on. We took many examples yesterday, and we stopped here. Okay, for now we are going to learn about the associative entity. The associative entity, actually, it's an entity itself. It's a table. It's considered as an entity, and it must have attributes. It must have attributes, and it's a relation at the same time, which links entities together. So it's supposed to be conducted between some tables, maybe the same table, two tables, or more than two tables. It's up to the scenario. But the associative entity, it's an entity and a relation at the same time. So the entity must have attributes, and the relation must link must link tables together. The point number 3, when should a relationship with attributes instead be an associative entity? So this is a very important question, and here we are going to learn when the relation could be an associative entity. Okay, here is the characteristics of the relationship, the associative entity relationship. So all relationships for the associative entity should be many. Should be many. So here, if you remember, Monday I explained to you, I told you sometimes two tables are connected through a relation, and one side here is many and the other side here is many, while this one is one, here, and here is 1. This is one case. And the other case is to have the opposite thing. So in this case here, 1 is this side and 1 is this side, and here this relationship, this associative entity has all sides must be many. All sides must be many. So this is one of the important characteristics. One of the important characteristics that we can understand based on this characteristic, that this relation is an entity relationship, an associative relationship or associative entity. Okay, this is the first point. The second point, the associative entity could have meaning independent of the other entities. So here, for example, employee could take a course, right? And in order to take the course, or after he get the course finished, then he is going to get certificate. He is going to get certificate. So every employee could have multiple certificates for many courses, more than one course, right? So the relation here is one to many. One is the side of the employee and many is the side of the certificate. And also every course should issue many certificates for every one certificate for every student, for every employee. So if, let's say, the enrolled employees number in a certain course, let's say 10, so that course should issue 10 certificates, one for each. Okay, so here the relation is also one at the side of course and many at the side of the certificate. That's why here the certificate has all sides many. Then here the certificate is considered an associative entity. And also the certificate has a certificate number and the completion date and maybe have other information. Okay, so here the certificate itself is an entity, right? So the certificate itself has a meaning, without the course, without the employee itself. It has a meaning. Okay, so the certificate physically is available thing, maybe physically or maybe as a soft copy, but it's an entity. It's a thing that's available, and this thing is interacting, or sorry, not interacting, is a result of our system. Okay, and that certificate should have information like certificate number, date complete, and so on. And this information should be saved in our database as an entity, because in future maybe some employees want to get maybe a replacement copy for the lost certificate, or maybe a certain organization wants to for example to hire somebody and wants to make sure that the certificate is original, and so on. So the data is necessary to be saved into the database. Then this data could be retrieved in future for any purpose. So as you can see here, the two sides of the relation here are many, and also the relation has information, has attributes related to it, and the relation itself has a meaning by itself. Okay, so all of these features are telling us that this relation is an associative entity. Okay, so the point number 3, the associative entity preferably has a unique identifier and should also have other attributes. Okay, so here the certificate by itself, it has a unique identifier, right? it has a certificate number which is unique, and this number is never going to be used with multiple certificates. It would be used only for one certificate. So it's unique identifier, and also it has other attributes. So here this condition is already fulfilled. So the associative entity preferably has a unique identifier and should also have other attributes. The associative may be participating in other relations other than the entities of the associated relation. Okay, this one is optional actually. It's not necessarily to be happen. So the associative relation or entity may be participating in other relations other than the entities of the associated relation. Okay, this one is an advanced scenario. I'm not going to explain it now, but it could be happen. So maybe this certificate or this associative entity, it may be connected to other attribute, to other entity, maybe here another one, and maybe here also another one. So these three are more than the associative entities, the entities involved in the associative relation or the associative entity. Okay, so here this option or this condition is not necessary. So it could happen, but the first, second, third characteristics are important. If we find these characteristics, that immediately we change our relation into an associative entity. So instead of using the diamond shape, we use the diamond inside the rectangle. Okay, so the last one, the last point, ternary relationships should be converted to associative entities. Okay, they said here, if you have a relationship with more than two tables, you should convert it immediately to associative entity. But this one is not 100% correct. Okay, this could be happen, but in many cases, there are ternary relationship which is not an associative entity. So the last point, this point is not a good practice. So just keep it in mind. If this comes to the exam, you should answer the same way. If, let's say, they ask you about the characteristics of the associative entity, you just write whatever we have here in this slide for the exam. But for the real practice, this point actually is not always correct. Okay, we shouldn't always do it. In many cases, we have ternary relationship, and that relationship is not an associative entity. Okay. Okay, let us take this example. I already explained the certificate, the employee, and the course. But let us go through what they have written here in this slide. Associative entity involves a rectangle with a diamond inside. Note that the many-to-many cardinality symbols face toward the associative entity and not toward the other entities. So the relation here, as I mentioned earlier, the relation here is supposed to be always like this. So the side of the many cardinality supposed to be at the side of the associative entity. Okay, do you hear me clearly, guys?
Yes, yes.
Okay, okay, good. Is there any question so far before I move to the example?
So far,
Okay, okay. Ternary relationship as an associative entity. Okay, as you can see here, we have business rules at the right side, and we have the diagram at the left side. So here, business rule number one: each vendor can supply many parts to any number of warehouses, but need no supply any parts. Need not supply any parts. Okay, so one vendor could supply multiple multiple times to multiple warehouses. So the relation here, as you can see, is one to many, and the many at the side of the relation. And here, rule number two: each part can be supplied by any number of vendors to more than one warehouse, but each part must be supplied by at least one vendor to a warehouse. So as you can see here, based on that, so each part could be supplied by multiple vendors and could be supplied to multiple warehouses. So here the relation is also many. And the other one, each warehouse can be supplied with any number of parts from more than one vendor, but each warehouse must be supplied with at least one part. Okay, so here also the relation is many. So the three sides of the relation are many, and also the relation has some information here, which is the shipping mode and the unit cost and so on. So here mostly because of these three things, and because of the attributes that we have related to the relationship, then this relationship is immediately considered associative entity. Okay, so we cannot make it diamond only. It must be a diamond inside a rectangle. Okay, here we come to the exercise number one. So in this exercise, actually, we are going to build an entity relationship diagram, our first entity relationship diagram. So this is going to be an assignment. Okay, so for each pair of sentences, identify entities and the relationship representing the sentences. Okay, so here we are going to read it together, to understand it together, to understand or to find how many entities do we have and what kind of them, what kind of attributes also we should give them. Okay, so the first sentence: each student must take one or more modules. Okay, so here, from here, we understand that we have something called student So this is the list of entities. First entity is student. Second entity is module. What else? Each module must be taken by one or more student. So here, from here, what is the relation between a student and model? Could you help me? What is the relation between students and model?
Is it one to many?
One to many. That means
Yeah.
one student can take many modules, right?
Yeah.
Okay,
Correct.
what's about the model? Is it is every model is for only one student?
One module can have many students.
Yes, so the relation is many to many, right?
Too many. Yes.
Yeah, the relation is many to many. So when the relation is many to many, that means we have something at the middle, right? We have a middle table. We should have a middle table. Okay, let me draw it for you here. So here is the student, and here is the module. Okay, so here at the middle we have something called we have something called middle table, right? Middle table, and here the relation is that many students can take many modules, and one student can take multiple modules, and one model could be given to multiple students. But we don't know what kind of cardinality here, because we still need to know what is the middle table. What is the middle table? We need to understand what is the relation between them. Which kind of I still use this. This confuses me. Drawing on the screen is terrible here. Okay, each customer must receive at least one delivery. Each delivery must, it seems that it's multiple scenarios. So, okay, let us go back to what they call it, paint here. Okay, so as I mentioned here, uh, student, and module have a relation, but this relation is many to many, as we agreed, right? And here for the many to many relation, we have to have something at the middle, okay, which is a middle entity or middle table. So let us think how the student could take the module. Is there any procedure, any operation that the student could do to get the to get enrolled in the model?
Registration. What about registration?
Registration or enrollment?
Oh,
Enrollment, right?
correct.
Yes. So this enrollment should have every student should be able to enroll in multiple courses, right?
Right.
Yeah,
Right.
and every model should be involved in multiple enrollment. So the two sides here are many. This is one part of the characteristics of associative relation. Okay, what's about the this entity? Actually, this entity is a relation. Is a relation. Why? Because it also has what they call it date here, and enrollment ID, for example, and this ID is a unique identifier, and it may have something called for example, who prepared this enrollment, or this will take us to another scenario. I don't want to use that. So it's enough. So here we can see that this relation has two attributes. It has a unique identifier. The two sides of the relation are many. Okay, so here this one is 100% confirmed to be an associative relation. Okay, is that clear, guys?
Clear, but one question, the associative entity must have two, or it can have many other attributes.
Two attributes, you mean, or two tables?
Uh, for example, the enrollment ID.
What is the example?
For example, what I mean is to attribute the enrollment can have more attribute, right?
Yes, it could have. It could have. It's no, there is no number for the attributes. It could have, for example, time. It could have the user name, or maybe prepared, like this, prepared, prepared by.
So it's not limited, right?
Yeah, it's not limited. Prepared by, and here maybe endorsed, 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 and this endorsed could take true or false. So if true, that means the enrollment is endorsed. If not, that means the enrollment is not endorsed. Okay, we could have many. We could have two, three, four, infinity number of attributes. It's up to you. It's up to the requirements of the user or the organization that we designed the system for. Okay, also the number of tables involved in the relation, in the associative relation, is not limited to two. Okay, it's not limited to two, but mostly the relation, the associative entity should be conducted between at least two tables, at least two tables, for one reason, for one important reason. If, let's say, we want to make a relation between the table and itself, so I said that every side, this kind of relation is mostly a one to many. The unary relation, it could be only one to many, or one to one. So if this one is one relation, the other side will be many, right? And this side is already many, so the other side here, it will be one. Okay, the other scenario is to have, instead of many at the other side, so it will have one here and one here. Okay, so in this case we couldn't get two sides of the relation to be many cardinalities. Okay, so that's why this couldn't be an associative relation, couldn't be an associative relation. I'm not saying that it's impossible to be, uh, at least in my experience, I never seen this. I never face any scenario that causes this kind of relation. Okay, so this one, this one is the characteristics mostly we have to find before we decide whether this relation is an associative or not. Okay, so this the sides of the relation, the cardinalities connected to the relation must be all many, and the relation must have some attributes, and the attributes should include a unique identifier. Okay, any question before I clean this?
No, no.
Okay. Let us take the other scenario. Each customer must receive at least one delivery, and each delivery must be for only one customer. Okay. Okay, now from here we understand that there is a customer, right? And there is something called delivery. But delivery is what? The delivery could have some items, right? That items could be products, could be food, could be whatever, right? So here we should have something called item. Then we have delivery. Okay, so here the relation is like this, and here based on this delivery, the delivery should have delivery ID, right? To be tracked, the delivery, the parcel number or something like that. So it's supposed to have an ID to be tracked, and also it should have a date, should have time. Am I right?
Right, right.
Yes. So when the relation has attributes, immediately we change it to an associative entity. Okay, this is based on my practice, based on my experience. Once the relation has attributes, immediately you change it to associative entity. Why? Because 100% the relation will be one customer could have multiple deliveries, and one item could be delivered many times. Okay, so by nature, once we have attributes, so it's immediately a many cardinalities supposed to be at the side of the relation. Okay, also here we have the identifier. So this is the second example. Is there any question about this?
No.
No question. Okay, let us take the other example here. A client may have an account manager. Each account manager has only one client. Okay. You have to read the things carefully. So from here we have client, right? We have account manager. So if we have account manager, that means we have an account, right?
Right, right, right.
Yeah. So we have to draw everything here, all possible entities. So customer or client would have account, and here we should have account manager. Okay, so here the account actually belongs to for example a bank, okay, or maybe a company that has generates accounts for their clients. But let us take the example of the bank. So if this one is the account and this one is the client, there's supposed to be a relation between the account and the client. So the first relation is owned by. Okay, this is the relation. And the other relation, I'm going to delete this because the account manager actually is a client, supposed to be recorded or registered as a client. Otherwise, he will never be known for the bank, right? Even if you have an account and you want to manage it by other person, then you have to bring the information of the other person, and they are going to register him as a client. After that, they can assign him as a manager. Okay, so here this is the relation of owned by, and let us just delete this. Okay, and let us draw another one. This another relation managed by. Okay, so managed by here is also another relation. Okay, managed by here, let us go back to the example. A client may have an account manager, may have an account number. So this one means optional, right? This one means optional. So this side is okay, let us think about it. Every account could have only one manager, right? Cannot be more than one manager. So this side is one account. Oh, sorry. This side is one manager could handle only one account. So the relation is 1-to-1. Okay, and every client could have an account manager. So this one is 0-1 and this one is 1. And this account is 1 owned by one person. So this one is mandatory 1. Mandatory 1. So the relation here is what they call it, a normal relation, because here when we own the account, this is never going to have any attributes, right? Because the relation doesn't have by itself doesn't have a meaning. It's not an entity. The relation is only between the account and the client, right? It's not
Correct.
like the certificate. It doesn't have an ID, doesn't have anything. The account has an ID, the account number, and here the client has the ID, and the date when we open the account is here. Date is not here, not related to the relation. Okay, so this relation is not an associative. What about the other relation? This one, is it associative or not?
No, no.
This one is not an associative unless the scenario change. If the scenario change, then it could be an associative. If let's say the account could have a manager, and the manager could be changed, then so one account could have multiple managers. It's one manager at a time, but in the system we must be able to save multiple managers for the same account. So for example, in 2018, a certain account, maybe account number 50, it was managed by Ali. Then in 2019, it was managed by Saleh, for example. And 2020, it's managed by Aini, for example. So here, we should have these records in our table, right? We should have these records in our table of the management table. So here, for the same account here, 50, 50, 50, we have how many managers? 1, 2, 3, right? So here the relation become many. You see, the relation become 1 to many. But at a time, this one is not enabled. This one is not enabled. This one is the enabled manager. So we have one manager at a time, one active manager for any account at a time. This records we cannot delete because this is the history. Maybe something happened into the account, and the parties wants to know who was the manager of the account and who is responsible for withdrawing money or transferring money to other account or so on. So that's why the information must be saved, must be kept into the database. We cannot delete it. So in this case, the relation is changed to 1 to many. And also, every client account could be managed by multiple managers. It's right, one manager at a time, but in the database we have to save all of this information, right? So here the characteristics are already confirming that this relation is an associative relation, that has maybe date, maybe time, and so on. Okay, and it could have an ID as well, which is a unique identifier. Okay, guys, is that clear?
Clear. But it is
Yeah.
when it is only we change the scenario, right?
Yes.
Okay.
Yeah, the first scenario, if only we want to keep the manager for a certain account, we only want to keep the information of one manager in the system for each account. And if the manager is changed, if the manager of for example account 50 is changed, then the new manager is going to override the previous manager. So in that case, our system will keep only one record for the manager for each account. So in that case, the relation is 1 to 1. Is that clear?
Clear.
Yeah. But if we want to keep the information about any manager who manages this account, no matter he is active or inactive, then it will require to have multiple records for managers of one account. So here the relation will be changed to 1 to many. Okay, we have many options, actually, many options to do, but the the required things from the company, when the company gives you or the customer gives you some comments like this or some information like this, then you have to follow. You have to take the proper design or the proper option. We have to fulfill their requirements. Otherwise, they will complain later. Okay? Okay, ERD exercise 3, they jump from 1 to 3. There is no exercise 2. Okay, exercise 3, relationship, add in the ratio. Add in the ratio. So here, this is all about library user who has a card, library card, and the user looks into the card catalog or the library catalog, and here the books are listed in the catalog. Also, the book attributes are filed in acquisition journal, and so on. So here we have many tables and many relations between them. Okay, let us see here. An automobile insurance company. Oh, it seems that this one is exercise 2 and this one is exercise 3. Sorry, it's actually it's not my slides, it's the slides sent from the coordinator. That's why I feel sometimes confused. Okay, an automobile insurance company needs to keep track of information about vehicle policy holders. The company has to store information of customer, car, and accident. Customer information is license number, name, and address. Customers can own one or more cars, where the car information is plate number, model, and year. Then a car not involved or involved in many accidents. If the car is involved in an accident, the information that will be stored is report number, location, date. Each car that is involved in accident, the damage amount will be estimated. Okay? So here, this paragraph actually is the requirements of the insurance company. So what is required now is to draw the entity relationship diagram. Okay? This one is an assignment. Exercise 3 is an assignment for you. Okay? So next week, I want you to send me the drawing. You draw the thing, then you write your metric number and name on it. Okay? So here I'm going to highlight some things. This company, this insurance company, need to keep track of information about vehicle policy holders. Okay? So here we have to highlight vehicle and policy holder. Two things. Policy holder is a person, right? This person is mostly the owner of the vehicle. And also we have vehicle that has information like plate number, model, year, and so on. Then here the information is stored. The information of the customer is stored. Then the car also need to be stored. The car information need to be stored. And also we have something called accident. The accident is an event, right? So this event could have date, could have the cost of the what they call it, the damage, and the location of the accident, the report number, and everything. So it's by its own is an entity, right? Here there is the customer information, 3 things. Here another hint, the customer can own 1 or more cars, where the car information is plate, number, model, and year. This is about the entities, about the attributes. A car not involved or involved in many accidents. So that means every car could have an accident or no accident, right? So the relation is the cardinality of the relation could be optional, right? Then here, if the car is involved in an accident, the information that will be stored in report is report, location, and date. This is the attributes. Then each car that is involved in accident, the damage amount will be estimated. Okay? Okay, let us vote. When you want to submit this assignment, Monday or Tuesday?
Monday, 0G.
Monday.
For me, it's Monday, but I think you need to ask others too.
Okay.
Tuesday's week.
If you submit it on Monday, it will be better, because on Monday we have other things to learn, so we don't want to go back. We don't want to go a step back. It will delay us if we make it Tuesday. I think it's better to make it Monday. So Monday, the first thing before Monday, you submit before the class. Monday morning, you submit the assignment to me. You send through the WhatsApp. Then during the class, I will start taking them one by one, and we correct if there is mistakes, we correct them together. Okay, so don't try to copy. If you want to find information from other places, okay, you can find, but when you find the answer, please understand it. Okay, because Monday, inshallah, don't worry, this is not I mean it's not a hard thing actually to do, and also the marks is not going to be high. It could be 2 marks or 3 marks about this assignment. Don't worry about it. Okay, I need you only to understand the context, then to find extract what is the entities, and every entity, what kind of attributes they have in the entity, and then what kind of relation it links them. Okay, just draw it by hand, by software, by whatever, I accept it. But I need to make sure that it's clear. Okay, then Monday morning, inshallah, Monday at the beginning of our class, I will go through them one by one. We discuss if there is any mistakes or something like that. We correct every one if we could have time. Okay, so Monday, please, Monday before 2 o'clock, everyone should submit the assignment. Okay, thank you guys, and if you don't have any questions, I'm going to end up this class, inshallah.
No question.
Any question?
No,
question.
All right.
Okay. Okay, so thank you for attending the class, and inshallah see you on Monday. Assalamu alaikum wa rahmatullah.
Waalaikumsalam. Thank you.
Waalaikumsalam.